Okay, another quite interesting development that I want to discuss are these prior fitted networks, PFNs. So they pre-train on synthetic data only, right? So, I mean, it sounds like a quite boring idea. Oh, you just pre-train on synthetic data. But it has this nice Bayesian motivation why this will work, right? That you are essentially fitting on a prior. And so there is this method called PFN that is for classification and regression that has gotten a lot of attention. They have a paper in Nature. They have a spin-out company because it seems to work really well for tabular data where deep learning traditionally, wouldn't outperform gradient boosted trees. Yeah, because then there's this other proposal, TAP-ICL, that is kind of a follow-up proposal. Quite nice. Follow-up from other people. And well, these PFNs are now coming into the forecasting space. So we have TAP-PFN-TS, which is from the research group that originally proposed TAP-PFN. So it's just a regular TAP-PFN trained for regression, and then they just do some time series specific inference. And it performs quite well, surprisingly, right? Then we have forecast PFN. That one uses now a time series specific data generating process to simulate data. I had a master student looking into this with more detail. It again has a quite dodgy evaluation where they evaluate only on one time series for every data set. So they say we evaluate on M4 monthly, and then you look at it and they use only the very last time series from M4 monthly. Yeah, then there's time PFN, and obviously there's Chronos 2. So Chronos 2 also heavily relies on simulated data, and they even have an ablation study where they run only on simulated data and show that it performs still really well. Yeah, so these models already achieve really quite decent results in forecasting tasks, and there's no risk of data leakage whatsoever, which I think is a very important point in this foundation model space. Yeah, so I think the future now, kind of what's next, I think the future will likely be multimodal. Because if we provide textual context for each series, these fundamental problems I talked about are addressed, right? So the fundamental problem is that I'm training a generalist, and that in itself is not a problem. But the problem is now if I go to my special problem, the question is, do I know exactly in which problem space I am, right? So for example, JetGPT is a generalist, but it works well because you just tell it, look, I want to talk with you about forecasting. I want to talk with you about biology. I don't want to talk about something else, right? And like the context is directly there. In forecasting, you don't have the context. You have 20 data points, and your method doesn't know, is this solar energy? Is that daily solar energy production? Is that the GDP of a country? What is it, right? And then it has to give you some sort of average forecast across everything it has seen, right? So, but if we obviously give it now this context and we tell it what this series is, then we should be able to train a really quite general model that can do all of this, right? Yeah, and in that sense, then the question is, well, what do we actually want to do? Do we want to replace the model or the modeler, right? Because as we've seen before, I said, well, if you use an LLM directly for forecasting, I've not really seen that work very well. But that's because LLMs are not good with numerical computations out of the box, right? And it's not just me saying that. I mean, the people who develop these LLMs, they know it themselves, right? So if you nowadays you ask ChatGPT, can you please give me the square root of 2,400,000 something? It's not going to just to use its inference engine to calculate that square root. It's just going to say, oh, look, here I implemented some Python code for you that does it. So yeah, so like LLMs are not really good at just these numerical computations. And now, well, obviously you can now easily say, okay, ChatGPT, I want to just use you not as an algorithm, but I want you to run that algorithm for me, right? So I'm not replacing the model. I'm still running ETS or ARIMA, but I'm kind of replacing the modeler, the data scientist, right? So ChatGPT selects for me which ETS, which ARIMA is the reasonable one, right? And I think that's an interesting idea because now you use it. Now you use the LLMs in that space where they're really strong and where what they're really intended to do, which is this textual inference, right? Okay. Yeah, but again, small word of caution. So if I say multimodal models, so that there are now some recent papers coming out, they claim they do these great multimodal foundation time series models, and then you look at the paper and they just run on these typical benchmark suits, and you say, oh, but there's nothing like there's no text here, right? It's just time series like ETTH, ETTM. Where do they have the text from? And then you see what they actually do is they use the LLM. They feed the series into the LLM and they say, LLM, please describe the series for me. And then ChatGPT says, this is a very seasonal series with trend and it seems to have a lot of noise. And then they use this text and feed it into their great multimodal pipeline to come up with a forecast, right? And so, I mean, well, if it works, it works. That's fine. The problem is they never have the evaluation to back it up. And obviously, you know, like there is no reason why this should work. I mean, you are now just competing with all the purely numerical algorithms, and you have to beat them. When I say multimodal, I mean that there's actually something in that text that helps you to forecast better, that gives you kind of an unfair advantage over the purely time series models, right? That's what I mean with multimodal. And that text can be many things, right? It can be kind of product descriptions that lets you figure out which products should be grouped together. It can be directly commands, kind of, or knowledge about the future, something like, I know that tomorrow this is going to go down, this series. I know I'm going to run this promotion in the future, but I've not put that into the data. Things like that, right? So that's where these things will really work well. Yeah, and there are obviously now some first proposals in that area. Again, things move very quick in this area. When you watch this video, probably there are already many more things and so on. But yeah, so for these forecasting agents, right? So one is Time Copilot. Another one that I know is the Chronolus AI. I mean, there are still more like LLM interfaces to traditional algorithms, right? So what Time Copilot does is something like you tell it, look, here's my time series, and then Time Copilot kind of uses the LLM to choose what it should run. You know, it says, oh, okay, it seems I should run ETS with these parameters, or maybe I should run Chronos 2, or maybe I should run this other foundation model. It just chooses a model for you, and then afterwards it gives you some explanations after the fact, kind of like the forecast goes up because there's a lot of trend. And I mean, you need to be a bit careful with these explanations because obviously it's a post hoc explanation. So the explanation doesn't come out directly of the forecast, but it's just kind of somebody later interpreting these forecasts. And that can be problematic. I mean, if you think about people that do, let's say, you watch a television news where they talk about the stock market, right? They are always very good at explaining, oh yes, and today Google went up because yesterday they did this and then people did this. So people are always very good at explaining why something happened. But they can never forecast the future of the stock market, because if they could, they wouldn't be there as some moderator explaining to you the stock market, but they would just trade and be rich. Yeah, so in some sense, I'm always a bit wary of these explanations. But, you know, if they make sense for you, if they help you to explain to your stakeholders what that forecast is, then I think that's a very good thing, right? So, yeah, and there are still LLM interfaces to traditional algorithms. I think where likely the future lies is to have more integration, right? So we've seen the LLM, like directly using the LLM for forecasting. It doesn't seem to work very well. Even some people claim it does. So you have the foundation models, but they are not able to kind of have this multimodality that you will need to interact more and so on. So right now you just say, okay, so I just get an LLM that calls the numerical model, but yeah, well, maybe this can be a bit more integrated. Okay, so with that, I want to wrap up the foundation models. So the foundation models have really seen an explosion of research over the recent past. They are promising. They can be used as fully automatic baselines. I would argue that we are usually still able to outperform them in most situations with our bespoke pipelines. And you see, another thing is that, okay, well, I have now a foundation model. The foundation model predicts one time series. But very often, a forecasting task is not that simple, right? You have a ton of covariates. Maybe it's a hierarchical problem. It's intermittent, right? And then the question is, can the foundation model kind of fit in there? And, you know, they are getting better. For example, putting in covariates into a foundation model was very difficult some time ago. Now we have Kronos 2 that claims it can do it well. So yeah, there's definitely progress in the field. But I would argue we can still, in many situations, outperform them. It's currently a problem that has no easy fix. Well, that not all, yeah, it has no easy fix in the sense that it's difficult to get an LLM and a foundation model that in every single task will outperform the bespoke model, right? That's because of these global model guarantees I've talked about. A possible fix are these multimodal models. Let's see what comes out in the future. But the takeaway from this is really you always need to do your own rigorous evaluations, right? So there's just no way around saying, okay, I do some modeling myself on my data. I do a nice evaluation with the holdout set on my data so that I really know whether these foundation models are suitable, whether they give me a certain benefit or not, and whether this works well for my case. And that's obviously, well, why we also talk about all of these things in this course, because I hope to give you the tools to be able to really do these evaluations and to make then later the best choices for you, whether, yeah, a foundation model, a deep learning model, or maybe still just AutoArima assembled together with AutoETS is the right thing to do. Okay, and just for some overall conclusions of our second session that was about deep learning and machine learning in general. So yeah, machine learning models, they work well if you have long high frequency series, or if you have many series from a similar source or external regressors, or if they are not even similar, but you just want to evaluate across all of them together. Yeah, if you do train deep learning models from scratch, you will usually need a large enough data set Right, and that can be a bit relative. I mean, CIF 2016 was won by an LSTM, and CIF 2016 has, I think, 100, kind of 100 or maybe like less than 100 monthly time series. So really a situation where I would have thought ETS will smash that for sure. Yeah, so like the data sets don't have to be huge, but you need a certain amount of data, and then you need to know what you're doing. Foundation models are now a great fully automatic baseline. We can still beat them with bespoke modeling most of the time. Different series need different types of forecasting, or at least different pre-processing. It is paramount that you perform an evaluation on your data with the right error metrics, reasonable conventional benchmarks to be able to assess whether machine learning and deep learning add anything and should be used. If you have low frequent data like monthly, quarterly, yearly, beating the classics like ARIMA, ETS, CETA, and ensembles of them, it's kind of on their home turf, so it's still a challenge beating them. So if you have these low frequent time series, certainly don't forget about these classic methods. Thank you very much. That's the end of part 2 of my training course.